You guys are on your textbook, page 335, blue notebook 306. You guys are going to copy down an equation of the axis, amplitude, what a sine function is, and a sinusoidal function. Okay? We're going to get on to all of these. On Friday, we did 6.1 and 2 together. You guys were to learn a couple definitions, what a peak, a trough was, what a period was. Were there any other ones? A cycle. You need to know what a cycle was. And you need to know if something was a periodic function. So, no, we can do. We can do a little quick recap here. Quick recap. Quadrant. Is this a periodic function? Why? What's that? It's got repetition. Where does the period repeat? Okay, so we assume it starts at 0 and it repeats at what number? 4, good. So we're saying right here it repeats, so it takes about 4. So the next one it repeats that is 8. So it looks like we have 2.5 cycles of this. Would this be a periodic function? A little. So, gentlemen, would the red line I've drawn be a periodic function? Okay. Yes or no? Take a vote. How many think yes? 2? If red is periodic. And how many think no? By the amount of people in class, it should be 25. Okay. It is not a periodic function because it does not repeat the same pattern over and over. If you notice, the wave goes longer and longer every single time. There's no repetition to that one. So that is not a periodic function. Are you guys okay with that? We can pick out peaks and troughs of the black one later. We've done that before. So let's go back. Today we're going to focus on sine functions, okay? So you need to know what a period was. You need to know what a cycle was in order to move on to this topic. You guys were to copy down all of those things before. I've represented a sine function. Okay, so here's our y and our x. Now, the graphs of a sine function are different from what we're used to drawing. Our x-axis is in degrees. Just these in there, okay? X-axis in degrees, y could be anything. We'll say it's height for now, okay? But essentially what that means is this 90 represents 90 degrees. 180 represents 180 degrees. 270 is 270 degrees. And 360 is 360 degrees. Yes, that's 270. This is talking about, you can relate a sine function to a circle, okay? Assume we have a circle, which I've drawn up here, that has a radius of 1. So here's our center, and the radius of this circle is 1, we'll call it. We're going to start from here. As I move along the circle to this point here, we call this 1. How many degrees have I moved? I've moved 90 degrees. So if you guys notice, when we go back down, at 90 degrees, my y is 1. Okay? So we always assume our sine function, our normal one, has a radius of 1. We're always relating to where we've started. So, as I keep going along the circle, let's say I get to here. How many degrees have I moved? I've moved 180 degrees, but, whoops, forgot it does that. At that point, if this is our y, remember this represents 1, I'm back at my 0 again. Oh, it always does that. So we take a look at this. After I've gone 90, I end up coming back down. My height is 0 again. I'm at the same spot I started at when I move 180 degrees. Same idea as when I'm drawing a circle. Once I've gone 180 degrees, I'm back in line with where I've started. From that, we're going to keep going around the circle. See here. How many degrees have I moved? 200? Oh, that was something else. 270. Okay? I can't complete the circle. We'll zoom in. So we've gone 270 degrees. At this point, this is our 0. Here's our 1. What point will I be at? -1. That's right. The radius is 1, so I'd be at -1, which makes perfect sense here. We've gone up to 90. We're at 1. 80, we're back at 0. And at 270, we're at -1 on the y-axis. And finally, a complete circle is how many degrees? 360 degrees. So at 360 degrees, we've gone up, down, and around. I'm back at 0 again for my y-axis. If this is drawn well, or semi-well, if you notice, if I were to cut this in half and then fold this half over, it almost completes the idea of a circle. Okay? It's just we're drawing as a continuous movement. We're not going back from where we were. So a sine function, it looks like a wave, is what we have right now. Do you guys have any questions about that to start? All right. Okay, so if that makes sense, our normal sine function is represented by this equation. Okay? We have our f at x or a y, depending on if we're a function or not. We're going to say f at x, okay? F at x is equal to sine x. That function right there, sine x, is represented like this on the graph. Consider this our theoretical model. As we go into tomorrow and stuff, we'll talk about translating and transforming this, moving this around the graph. Now, the period of a sine function. Can anyone tell me how long the period of a sine function is? Let's see, if I'm at 180, here's my origin. So I've started here. I'm going up. When I get back to that level, am I heading up? No, I'm heading down. So where would it end at? 360. A period on the sine function is 360 degrees. So here's one period on the sine function, okay? We started on the y-axis. That also means the sine function can go the other way. I can go backwards with it. It's a continuous. It has cycles to it. So I'll quickly draw on the rest of this. Okay, so I've drawn on the rest of the numbers, and we've gone negative because we're to the left of the y-axis. So according to the sine function, I'm heading downwards. It looks like I'm going to be looking at the pattern at -1 at 90, 0, 180, 270, I'll be at +1, 360, and -450. So let's continue this wave. If you guys notice again, the period is still only, not only, but it's still 360 degrees. So I go from 0 over to -360. I still completed another period. So I have 2 periods in here. Our cycle consists of 2 periods. And if you look at it, it's a little backwards from what we had before. When I'm at -90, I'm at -1. But at +90, I'm at +1. So let's go back to our circle again that we've drawn. If I'm going in, we're going to call this the positive direction. Okay? At 90 degrees, I'm at 1. But if I were to reverse that and go the other direction, I'm at -90 degrees, which means I'm at what? -1. All that is say we're starting at this point. Consider that we're always drawing a circle. And at this point, if I were to head upwards to the right, that's a positive direction. If I were downwards to the left, I'm going in a negative direction. So at negative 90 degrees, my y-coordinate is negative 1, which makes sense. It's right here. And you can continue the pattern. Do you guys have any questions about this? So remember, for what I've graphed right now, guys, this is the equation we're using. The equation can differ. We're going to get into that in separate days, but for today, we're just dealing with f at x equals sine x. It's our basic equation. So at our basic equation, this is our equation of the axis is always at 0. We're always going to start at 0. Okay? Okay, we're going to keep moving then. Let's go through these definitions. So the equation of the axis. The equation of the axis is talking about the middle of the wave. So the equation of the axis is going to be drawn horizontal. If you guys notice, I've drawn our periods. I have vertical lines kind of separating the periods. The equation of the axis is going to run through the dead middle of the wave. Okay? So where would the middle of this wave be? Yeah, well, why is that 0? It's right along the x-axis. So we will use green, I guess. Our equation of the axis is right through the middle there. Our green represents it. That's the equation of the axis. Okay? Right now it's at 0. That means the distance to the peak, here's one of our peaks, and one of the troughs is the exact same. How far is it from the equation of the axis to the peak? It is 1. And from the equation of the axis to the trough, it is, negative 1. Still the unit of 1, right? We've still traveled 1. So the equation of the axis is the middle. It's the same distance to the peak and the trough, 1 unit, which refers to amplitude. If you guys look at your definition of amplitude, amplitude is trying to figure out how far it is from the equation of the axis to a peak and to the trough. So what would the amplitude be of this equation? 1. Amplitude of this equation is just 1. From the equation of the axis to the peak, we've traveled 1 unit, and the same idea when we're heading downward. So amplitude is equal to 1 in this, okay? One way you can figure that out is you can take the peak. Let's make sure I have the exact. If you take a peak and subtract the trough and divide by 2, you can always find the amplitude. So I've used words there, which is kind of confusing. But if we look at our peak, we'll call it P and T, okay? So if you take P, subtract T, and divide by 2, peak, subtract the trough, divided by 2, you'll find the amplitude. So our peak was at 1, and our trough was negative 1. And the equation tells us to subtract these numbers and then divide them by 2. 1 subtract negative 1 is going to give us 2. Divided by 2, amplitude is 1, okay? Consider that your idea of amplitude. Take the top and the bottom, subtract them, and divide by 2. It'll always give you your amplitude. This is a sine function. That's what we've drawn. It's also known as a sinusoidal function. All that sinusoidal means is this this cycle is going to repeat over and over and over again. My graph only goes from negative 450 to positive 450, but this pattern is going to go on forever. So sometimes an equation may ask you to draw something in a certain domain, if you guys remember. Right now, I've drawn this graph to exist in this domain and range. My domain is x is every real number such that it is greater than and equal to negative 450 degrees and less than and equal to positive 450 degrees. So that's how far my graph happened to go. That's all I've drawn of it, between negative 450 and positive 450. And the range, y is every real number between positive, and negative 1. So from looking at the graph, we figured out the range was 2. We went from 1 peak to 1 trough. And the period, so when it recycled, was after 360 degrees.